But, I might just go in for a long here. Because 55 does look nice with the potential delta trap candle. Good push up. Let me see what 5 seconds looking like. Oh, big push up. Damn it. Yeah, that would have been a good one right there for me. I think it still might be a decent one.
Order filled.
Yeah, we're gonna try one long here. Alright, break even.
Stop filled.
Damn. Got stopped out right 32. It went up to right here. Yeah, so it went up to like 39.5. Ooh, look at that push. I might try again.
Order filled.
Oh, it should
Target
go.
filled.
Nice. All right, yep, and we're done for the day. Overall, not too bad of a day. Did get stopped out quite a bit, maybe like 2-3 times. The reason why I also just wanted to go into this quick scalp, and look, wow, nice, we got out right at the top. Nice quick base point. The reason why we wanted to do a quick scalp there is because I saw this good push from this demand zone up, and if we look at the 144, it had some good buying pressure going into it, so I felt a little bit more comfortable going into there. I waited a little bit for a retracement. It came somewhere down here, and I was like, all right, I'm in. So I just needed a quick base point, and then also the 233 range, it closed with decent delta number right here, which signaled some strength to me. So yeah, that's why I went for the quick scalp those 2 times, one right here and then another one right here. Obviously, if I held right here, which I probably should have, the reason why I actually entered down here first was because we can see that this up close candle was relatively strong. Yeah, that's honestly the reason why I entered long there for a quick short or a quick scalp long. And
Order filled.
you can see, like, even if I held on to it, it would go up a little bit, the tiniest bit more. But this, if I entered here 32, it's like a 30-point play, but
Stop
it's always better
filled.
to just secure nice little base points, in my opinion. So that's that. We're up. We are up about 350 on the day, so not too bad. But overall, yeah, pretty decent.
You might be interested in seeing what a Jane Street interview is like. We grabbed one of our trading new hires, Andrea, and had Graham, a more experienced trader, ask her a problem that we used to ask in actual trading interviews.
Hi, I'm Graham.
And I'm Andrea. We're both traders here at Jane Street. Graham's been here for a couple years now, and I just started full-time this year.
We get a lot of questions about our trading interview process and what we look for in an
Order
interview.
filled.
Our interviews can cover a lot of different things, but typically you would spend most of your interview time working together with your interviewer on a challenging,
Target
and
filled.
fun, quantitative problem. In this video, we're going to give you a sample of what that might look like, with me as the interviewer and Andrea as the interviewee. Thanks, Andrea.
Yep, of course. And by the way, this question really was new to me. I've never seen it before.
That's right. I asked Andrea a question that feels like the kind of question we might ask somewhere in our interview process, but of course, it's not a question we're actually using right now. At the end of the video, we'll recap a bit to discuss how it went and some things I was looking for. I'm going to describe a casino-style game you might play. This is just a one-player game where you'll have various options, and I'm wondering what you would do to maximize your earnings from it.
Okay.
So in this game, you have a 20-sided die. So a die with the numbers 1 to 20 on the faces. And at the start of the game, it's on the table and the one face is facing upright. Now, you're going to have 100 rounds. And in each round, you have 2 options. You can either roll the die, replacing whatever it's currently showing with a new number, or you can take a number of dollars from the casino equal to the current face.
Gotcha.
And my question is, how would you play this game? And how much money do you think you'll make on average?
How many rolls do I get? Is there any cap?
No, you have 100 rounds and you can take either option on each round, but there are no limitations to
I
other
see.
than that.
And just to clarify, to roll again, I pay?
There's no paying. If you take the roll again option, you use your turn up and you roll the die, but that's all that happens.
Okay. Then can I just keep rolling until I hit a 20 and then take my money and leave? Or
Sorry,
am I missing something there?
No, that's okay. But when you take money, the game does not end. So if you take money, you still keep going until you've played 100 rounds.
Oh, wait, sorry. There's 100 rounds?
There's 100 rounds, and on each round, you can re-roll the die or take money. And neither of those options ends the game. You can take money multiple times.
Oh, gotcha. And you just keep doing this for 100 rounds and whether...
Yeah, exactly.
Okay, cool. And sorry, so when you take the money, do you re-roll after that?
No.
But it keeps going for 100 rounds?
Order filled.
Wait, do you have sorry, I just like to walk through this.
No, that's fine.
If I rolled it 3 times and then I hit a 17 or something and then took the money,
yep.
What would happen after that for the other 97 rounds?
You now have 96 rounds remaining, and there is a die with a 17 upright on the table, and you can choose between taking $17 again or rolling the die.
Oh, okay, I understand now. Sorry.
That's fine. It's a bit of a contrived scenario.
Gotcha, okay. So in this case, let me think.
Stop
Chances
filled.
of rolling a 20, I would guess it would take me around 20 times to achieve that. I'm wondering, so one strategy that I would consider is re-roll until you hit a 20, and then just take 20 for every round after that.
Yep, I agree. That's a thing you could do.
Yep, so now I'm just balancing that strategy with rolling until I hit, say, anything greater than, 18 or greater, and then keeping that for the rest of it, and thinking about how those two compare. I'm just going to, try out, the situation of, rolling a 20 versus rolling a 19 or 20.
Okay.
So I guess for 20, that would just mean that I roll on average a 10 for around 20 rounds. So let's say that's approximately $200. And then for another 80 rounds, you roll 20. So that'd be 1,600. So then that strategy, I would expect to get 1,800 from.
Oh, sorry. Just to clarify, on the rounds where you rolled the die, you didn't get any money.
Oh,
it's either roll the die or take money.
Gotcha. Okay, I see. So in that case, then around 1,600 is what I'd expect to get for just 80 rounds, which I roll a 20. Then let's say I'm a little more lenient and then I will accept a 19 or 20. So then that would take me 10 rounds to get there. And then I would have 90 rounds getting let's say a 19.5. So then in that case, I would expect to get $1,755, or let's just say $1,750, approximately that. Okay, so then that strategy seems better than the previous one. I'm just gonna try going down by with one or two and see at what point I feel like I've maximized.
Yep, sounds very reasonable.
Okay, cool. So then with now 18, 19, or 20, then that's 3/20ths of a possibility. So that would only take me around a little under 7 rounds. And then that's I have 93 chances-ish to get something 19. So, Okay, so then that gives me like 1767, which does look like slightly better than the previous one. Okay, I'll just see another one. If I accept 17, 18, 19, 20, that would take me 5 rolls on average. So I have 95 chances to get a 18.5. So that looks like 7. Okay, so that looks like a little lower than before. I'm getting like 17, 57, 58. Okay, so in that case, I think I would go with the strategy of rolling until I hit a 18, 19, 20, and then keeping it from there.
Yeah, no, that sounds really good. And just to clarify something I think you did when you said, okay, so it's going to take me this many rolls to roll a 18, 19, or 20, and then from then on I'm going to get a 19. Where did that 19 come from?
Yeah, I was thinking that if it's an 18, 19, or 20, those seem equally likely, and thus I'm taking the average of the 3.
Yeah, okay, good. Nice. Okay, now let's move on to a slightly different version of this question, which is actually going to be more like you thought it was at the start.
Okay, gotcha.
So now I'm going to change the question so that when you take the money, you also take the die off the table. And so you have to roll it again before you can take the money. So this time the die goes away after you take the money, and you have to spend a turn rolling it before you can take money again.
Okay, I see.
So I'd like to know how you think this version of the question changes.
Okay, sounds good. So let's say if I have my first inclination is I would be willing to accept a much lower number to take the money and then re-roll. Let's just say if I have a strategy that's like I accept the top half of numbers, like 11 through 20. I'm just thinking through what that would look like. Okay, so in that case, half the time I would take money and half the time I would re-roll. Wait, sorry. Just to make sure I'm understanding this. So every time I can take the money.
Only if the die is on the table. Like if you once you've taken money, you're going to have to roll the die again before you can take money again. So,
okay. So if it's 100 rounds, what's preventing me from just taking the money every time? Because positive money is better than zero money. I think I'm still misunderstanding something.
Oh, sorry. So once you take the money once, the die goes away, and then you have to roll it before you have the option of taking money again. So, and that uses up a round. So a thing you could do is you could roll the die and take money, and roll the die and take money. And that's used up 4 of our turns.
Oh, I see. Okay. Versus another strategy would be to roll. Oh, I like that. And then take the money and then roll. I see. Okay.
Yes,
that makes a lot of sense now. Thanks.
No, sorry. This is a bit confusing.
Yeah, all good. So yeah, let's say I have a strategy that's like take the top half of numbers. So, I guess the way that I would imagine this playing out would be like the average sequence is I roll it. I am not half. It is something like maybe less than 10 or below. I roll it again. Oh, now it's 11 to 20. So then I use up like 2 rolls and I get something that's like, I use up 3 turns, roll, take money, like that sequence. And then I would get 15.5.
Okay.
Payout from that. Versus
the 15.5 being the average of the roll
11 through 20.
Yeah, okay.
Exactly. Versus, I guess, like the baseline strategy of just like roll, take whatever it is, roll, take whatever it is. That uses up like, I guess, I could play that sequence through 50 times and then get like 10.5 every time.
Okay.
So then let's just say like baseline strategy is you make $525 and then you call that. Versus if I do the 3-turn strategy and get 15.5 every time, I could do that like 33 times. So that looks like that would make me 5 of $511. Okay, so that seems a little bit worse than the other strategy. Okay, cool. So then I think now just finding like maybe the strategy looks similar to I will take the money for any roll above N and roll again for anything below.
Yeah, that sounds good.
Yeah, cool. Okay, so a matter of finding which one it is. So I guess the number of times I would have to do this roll, I guess we can think about the percent of numbers that I would accept. So let's say if I accept like the fraction x of numbers of the 20, then it would be 1 over x would be the number of 1 over x, and then plus the take the money, so plus 1 would be the number of turns I would have to use up. And then that means I can play this game through 100 over all of that times.
Yep.
So I'm just going to simplify that a little bit. So like 100x over 1 plus x would be like the number of times I can play. Play through the sequence. And then on average, the payout I would get from that would be, let's see. So if I took like the top x, that would be 20 times x, and then averaged with, I'm averaging 20 with 20 minus 20x. So then in that case, it's just 20 minus 10x would be like the average payout from all of those things. Cool. Okay. So now it looks like I am going to get a function which I can maximize. So that'd be 1000x times 2 minus x over 1 plus x. Okay. Cool.
Yep. That sounds reasonable. I don't think I'll make you do all the algebra to maximize this, but just tell me quickly how you would if some mean person made you do it.
Yeah, sure. I would just take the derivative, set it equal to 0, do a sanity check to make sure this is like a maximum type thing, and see if it is, I guess, above 525, which is my current best.
Yeah. No, I'll believe that'll work. So I think as it happens, if you do this, you will find that you should actually take anything 6 or higher.
Yeah, that makes sense. I was expecting somewhere between 1 and 10. So, yeah.
Yeah. And I guess there's a cute way to see this. So you, I think, calculated that you were going to make about $500 over 100 turns, right? So how much money can you make each turn, roughly?
$5.
So should you spend a turn picking up a 7?
Yeah. That makes a lot of sense.
And that way you get to skip the algebra.
Yeah. That's really nice.
Okay, cool.
Yeah.
So let's move on just to one more variant of this question. So let's go back to the first one where you didn't have to, where you got to keep the number on the table between rolls. Well, almost. This time, the casino gets to play. Once you take money, the casino gets to choose whether it wants to re-roll the die. And if it wants to, it re-rolls the die. This doesn't cost your turn, but the value of the die changes.
I see.
And the casino goal is to minimize the amount of money you make.
Reasonable.
Now, this is complicated enough that maybe we can't solve it exactly, but I'm curious to hear how you think this version will work.
I see. Can the casino re-roll once or any number of times until
they get the option to re-roll once every time you take the money.
Okay, cool. And this is back to the first version where I can take the money.
If you take the money and the casino chooses not to re-roll the die, then that number is still available for you to take again next round. If you take the money and the casino does re-roll the die, then a new number is available for you to take next round if you want.
Okay. Makes sense. My first guess about how this would go is if I play with strategy, I will accept anything above N or higher. Casino has a strategy like I want to re-roll for any like X or lower. We will have, perhaps at some point there will be some number, say like 10, in which case I just accept the 10, casino just also accepts the 10, and then we just continue. That's like the equilibrium position. But
Yeah, that sounds reasonable.
Mm-hmm.
Do you have a guess of roughly where this number will end up being?
Let me think. Well, if I play the 18 or higher strategy, casino is certainly going to re-roll me on that because that's me maximizing for myself.
Right. So let's say you roll a 19, you take it, the casino re-rolls.
Yeah.
Now what happens?
Casino re-rolls, and now I think, darn, my strategy's been foiled. I don't get to keep the 19. So
Yep.
I would probably just have to accept a lower number. Like, then my strategy might become, I will accept 15 or higher, and casino sees the 15, thinks, if I re-roll, the expectation is like a 10.5, so I should definitely re-roll that. Yeah, so I would guess like 10 or 11, something there where we both don't have like too much incentive to re-roll and try.
Okay. Yeah. So I believe the answer should be down near 10-ish. Okay. So you're saying you'll play the strategy of take money on 10 or higher, 11 or higher? Just
yeah.
It doesn't matter, but give me something to be concrete.
Yeah, sure. 10.
10 or higher? Okay. And so what do you think the casino is going to do?
Well, if it still sees like a 15 or something, it will also re-roll for me.
Okay.
And bring me down for the next time. I guess if it lands on a 10, the casino may just let me keep it because 10 is lower than the expected value of their next roll. So
why don't we imagine playing this out and see how it would go? Like, see how much money you'll make. So just to be concrete, you're playing the strategy of take money when it's 10 or higher, and the casino is playing the strategy of re-roll 11s or higher?
Yeah.
Okay. So how much money can we see you'll make in this game?
Sorry, can the casino make in this game?
Sorry, how much money will you make in this game? Like if people play these strategies.
Oh, gotcha. Let's see. So if I roll let's say like it's around half chance that it might be easier to think about. Let's say like casino and I both just have the same strategy of like 11 or higher.
Sure.
Like we do our move.
So you and them both agree that 11s and higher are good for you, and so you want them and they want to re-roll them. Okay, sure. Yep.
So this seems like an oscillation between like if I roll a 10 or lower half the time, then the casino will just will not want to re-roll for me. Versus if I roll an 11 or higher, the casino will immediately re-roll the one after.
Sorry, just to clarify, the casino only has the option to re-roll once you take the money. They don't just get to re-roll every turn.
Okay, yeah, gotcha.
Yep. No, keep going.
So if I say like 11 or higher and I decide to keep it, then the casino will re-roll me on it.
Okay.
So, in that case, so like, let's say the situation ends up with me making like $15.5 and then casino re-rolling. So then after that, I kind of start from scratch. So like every 2 rolls, I fill my criteria of 11 or higher.
Order filled.
I get to play like 50 times this sequence of events and get like 155 from those. So then I guess I expect to get like $775.
Target filled.
Playing this strategy.
Okay. Yep, that sounds pretty good. Okay, so how much money are you making per roll here?
In that case, I'm making like $7-8. So in that case, maybe that means I should change my threshold.
What do you want to do with it?
Let's see. Okay, so if that's 7-8 per roll, then if I get an 8, I should think, not bad, and maybe just take the money.
Yeah, very possible.
Yeah.
Why don't we just calculate how that one goes and see if it's better?
Yeah, so that seems reasonable. Okay, so if I go 8 through 20, 28, so then like 14 on average, and I get to play this through 13/20ths of the time. So, and sorry, remind me, taking the money, that is a move?
Yes.
Okay, gotcha. So then I'd expect 20 over 13 plus 1. So 33 over 13 is like the number of, is how long a sequence is?
I think maybe you don't want that +1 because you get to see the casino's initial roll for free. Like the casino gives you a random start.
Right, yeah, okay, they gave me that one. Okay, sounds good. Cool. So then 100 over that. So then I get 13 over 5, which is 2.6. Wait. What did I just do? Wait, sorry. So there's 100 rounds, and then I have 100 rolls as before, and then each sequence takes me 20 over 13 times. So then, okay, yeah. So then I got to play this through 65 times. Cool.
Yep,
and then 14 each times. Okay, so that's 130 times 7, and then I play it, $910. That is more than before.
Yeah.
Cool. Okay. In that case, I should increment by.
I think I won't make you iterate this anymore. But the answer is probably somewhere in between the two.
Yep.
Yeah. Okay, that's really good. I think we'll stop the interview here. Of course, in a real interview, there might be more questions, or I would stop at the end and ask Andrea whether she has any questions for me about Jane Street or the internship or she might be applying for or anything else. But for now, that's good.
All right. Thank you so much for your time.
Thank you.
So, for the benefit of the people watching this video, let's talk about how we think that went. First of all, Andrea, I think you did really well at that question.
Thanks, Graham. I'm still kicking myself over a few things, but overall, I agree. I think that went pretty well.
And in fairness, you are already a trader here, so I'd expect you to do well. Not just because you're smart, obviously, but also because of how much experience you have working on problems like this one. So, if you're watching this video and you feel like you wouldn't necessarily have been able to get as far as Andrea did or make progress as fast, don't be discouraged by that. So, anyway, it initially took us a minute or two to really get on the same page about what question I was asking. That's totally fine. It can take a while to wrap your head around a new problem, and it was really good that Andrea kept clarifying until she understood what I was asking.
Yeah, I wasn't quite sure how much to push there, but I figured it would have been really sad if I did a bunch of work on a question that turned out to be the wrong question.
Yeah, that would have been unfortunate. I think it was pretty good to keep clarifying. And that leads me to communication more generally. I thought you did a great job of talking me through your thought process. Sometimes that just convinced me that you knew what you were talking about, and other times it helped me know when to give you a hint or correct a misconception. We recognise that it can be hard to think and talk at the same time, and we really don't expect candidates to talk just quite as much as you did. But I think you demonstrated why we do find it important to think out loud.
Yeah, this is some advice I remember getting from my interviewers back when I was going through the process myself. They encouraged me to think out loud, and it was really helpful. Of course, it feels a lot more natural now that I've been working here for a bit. I spend a lot of my day thinking out loud. But I remember having to be pretty conscious about it when I was interviewing.
And onto the quantitative aspects of the question, I thought you did a good job of thinking about the problem and breaking it down into smaller and more solvable pieces. I liked how sometimes you would work through a strategy to see what happened, or if it would spur any better ideas to work on, even if it wasn't necessarily going to be the best strategy overall. We find that these are helpful problem-solving techniques, and in general, this process of iterative and collaborative problem-solving does better replicate what having a conversation on a trading desk here at Jane Street might look like. And when I did give you hints, you were really able to take them and run with them.
Yeah, those are much appreciated. Well, thanks, Graham. This was super fun to work on. It reminds me of my own Jane Street interviews back in the day, which were also tons of fun. To be honest, I was quite nervous leading up to them. They were some of the first interviews I had ever done. But my interviewers really put me at ease and made the process feel more like an exciting discussion than an interview.
Great. Well, we hope you enjoyed this video, and best of luck with your interviews.
Hi, my name's Nolan. I'm a software engineer at Jane Street. I've been here for about 6.5 years.
And I'm Grace, also a software engineer at Jane Street, and I've been here for about 2.5 years. We put together this mock interview because we know that interviewing is a stressful process and people come in with different expectations. So we'd just like to show you what a Jane Street interview might look like and share some advice.
Well, we hope that at least some of this advice will be useful for any tech interview you do. We're both Jane Street employees. We interview for Jane Street. So we do expect that some of the advice is going to be specific to our own interview process.
So the video itself is composed of a mock interview followed by us doing a recap of the interview. You can find some of the timestamps in the description below if you'd like to jump around and take a look. Hey, my name's Grace. I'm calling from Jane Street. Is this Nolan?
Hey, Grace. Yeah, this is Nolan.
Awesome, Nolan. It's nice to meet you. We were scheduled for an interview around now. Is now still a good time for you?
Yes, now is great.
Awesome. And since we'll need it for the bulk of the interview, are you next to a computer with internet access?
Yes, I am.
So why don't I go ahead and read you a link that'll get you dropped into the shared editor we're going to be using for the interview. And we'll make sure that our technology works and we can kind of talk about the shape of the interview.
Great, yeah.
So just let me know when you're ready to type in the link.
I'm ready.
Awesome. So it's cpad.io/6005.
Cool, I think I am in.
Awesome. I think I see your name at the bottom.
Yes.
Can you just type something to make sure that I can see it? Awesome. Cool. Do you see that I've typed?
Yes.
Response. Sweet. So our technology works. That's great news. So a couple of things before we jump into this interview. The bulk of the interview today is going to be us working through a question in this shared document. I'm sure this is not how you normally write code. It'd be surprising if you normally wrote code talking to a stranger on the phone in a web browser. So a couple of things to try to make that a little more pleasant. So first off, please write in whatever language you're most comfortable in. There's syntax highlighting for a lot of popular languages in the upper right corner of your screen. And if you want to write in one that's not there, that's fine too. So you should feel free to change the language
cool. Yeah,
to
I'm
whatever you prefer.
Go ahead and use Python 3.
Awesome. Sounds great. So another thing to note is that we're not going to be running your code. So while I'd like you to write real code, so code that given a compiler or interpreter you can make run, if you do the equivalent of missing a semicolon or something like that, that's totally fine. And similarly, I'm not expecting that you have the standard library for your language of choice memorized. If you forget the name of a common library function that exists, just say something and we'll agree on a reasonable API for that function.
Sure, sounds good.
Awesome. And then one last note is just kind of like high-level advice for what I'm looking for. We really value clear and correct code here. And so by default, I'd like you to focus on that over writing super efficient code right off the bat. That doesn't mean that you shouldn't try to make your code fast, and I'm always going to be happy to come back and ask you to make something faster if I'd like you to. Just that by default, I'd like you to focus on clear, readable implementations.
Okay.
So I'm thinking about like code structure, variable names, things like that.
Cool. Sounds good.
Cool. Awesome. And I'll leave a chunk of time at the end of this for any questions that you've got for me about the interview process or Jane Street more broadly or whatever's on your mind. But otherwise, do you have any questions about what I just described before we get started?
Nope, no questions about that. Sounds great.
Awesome. So let's jump into it. Today, we're going to be dealing with unit conversion. And specifically, I would like to ask you to write a program that can answer unit conversion questions, like how many meters are in an inch, given a big list of conversion facts about units. So by way of example, I'm going to paste in some example facts and queries. In the coder pad. So a few things to note. So the top has a list of example facts, and the bottom is like a list of example queries that you might be able to answer in this way, given those facts. You don't have to do any parsing, so I'm going to pass the facts to you as string, float, string tuples, and the query is a float, string, string tuple.
Got it. Okay, cool. Yes, makes sense.
So do you have any thoughts on how we might be able to kind of like write a function that will be able to answer these queries given those facts?
Let me think a little bit about this. So what are we going to want to do? We're going to take in all of these facts. Are there kind of like two different steps? Like, should I expect to kind of write a function like, parse facts, something like this, that returns something, and then answer query facts or something like that? Like, is this a kind of a reasonable thing? Or would you rather that I kind of parse the facts every query?
I think this seems reasonable.
Cool.
What do you think?
This seems a little nicer,
parse the facts?
just so that I can do some pre-processing up front to kind of make answer query simple. I guess I could do that every time, but it seems a little nicer to do all of that work once. So let's think a little about what type of work we want to do here. I guess like conceptually we have a couple of different like disjoint graphs, right? Like there's the like distance graph and the duration graph in this question or in your example. And
what do you mean by graph?
Yeah, so like we have one node in our graph is maybe meter, and we have an edge between meter and foot. And that edge has some annotation indicating that a meter is equal to 3.28 feet, similar for feet to inches. And then, maybe we have like one big graph and it's just not fully connected, but we have kind of a separate series of connections between hours and minutes and seconds. Right, and I think like this...
Gotcha,
Go ahead.
Go ahead. I just wanted to confirm. So parse facts is going to take that list of facts and like return some sort of like set of graphs or graph. Is that what you're thinking?
Yeah. I'm thinking about like, I think at a high level, like let's imagine that everything was connected here. Let's imagine that there is no duration. Then like our algorithm is like pick some arbitrary starting point. Maybe we could be clever about what that starting point is. But like pick some node in this graph. Sorry. Very clearly, never mind. We pick the node that is equivalent to like meters here because we're answering the 2-meter question. And then kind of do some type of like BFS or DFS. I don't actually know off the top of my head which would be more appropriate here. And keeping track of the state stored in our edges until we find our inches node. And then apply some conversion based on that state, multiplying like 2 by the various floats that we've stored at that edges to get 78.72. And I guess like when doing that, the thing we want to do is, or I guess like if we explore every node that's connected to meters, and at no point do we find inches, which isn't going to happen, but like this does happen with inches and hours, then we want to return not convertible instead. So I think like actually the state that I want to store to start out is going to be something like a dictionary that maps strings, units, to some class that represents a node in a graph. And then those nodes in the graph will store like nodes store like a float node tuple, where float is kind of the way that we want to convert between the node that we are operating over and the node that we're linking to. And the node that we're linking to is some other unit that we can convert to. So it stores some like, edges type of class variable. And then our algorithm is going to be take in a string, look it up in the dictionary, do some traversal over the nodes kind of stored in that dictionary, and return an answer or not convertible. I think there is a clever way to keep these graphs that we're building up as small as possible. I have this vague recollection of a thing called union find, but I don't actually really remember how it works off the top of my head. I would need to go look it up. Is it all right to kind of write the naive thing that I've sketched out here, or do you want me to do something a little faster?
Absolutely. Let's go for the naive solution and see how that goes.
Cool. And is the thing that I've described like somewhat reasonable? Does it make sense, or is it unclear?
I think this makes sense to me at a high level.
Okay.
So you want to construct a graph that maps from some units to some other units, and you're keeping track of in your graph what that conversion rate is. Does that sound right to you?
Yeah. So let's maybe, for the sake of being super explicit, we can make a edge class. Do you take self in Python 3? I don't remember. Multiplier.
We can just go for it.
Node. Self.multiplier equals multiplier. Self.node equals node. Class node def net self. And we are going to take in like a unit. So that's something like m or in. Self.unit equals unit. Def add child or add edge. Self and multiplier and node other unit. Something like this, self.multiplier is multiplier, self.other unit equals other unit. So hopefully, maybe that's a bit of overkill, but hopefully that makes it a little clearer how I actually want to store this data. And then we're gonna, like I said, have some dictionary that tracks individual units to their node class. So we can call this whatever, name to node, it's a dictionary for, and then you said this comes as unit, left unit, multiplier, right unit in facts, is that right?
Yeah, that seems right.
Float or string, float, string? Or is it, yeah, okay.
String, float, string.
String, float,
seems like
string.
a reasonable representation.
Great. Okay, so, let's see, what do we want to do? If left unit not in name to node, equals node of left unit, name to node, left unit equals left node. So we want to do that. If right unit, all right, this is, surely there's like a nicer way to do this in Python, but I'd like to at least kind of sketch this out before I simplify it at all. And this is actually name to node, not name to name, which wouldn't make a lot of sense. Right unit times left unit times right unit. So final multiplier, left unit from unit to unit equals query. So I think my plan is just going to be to keep this final multiplier around and multiply right at, oh no, never mind. Okay. Starting unit amount. So now what do we do? Let's have some, so we're gonna kind of have some list that represents, how do we want to do this?
Why did you change it from starting amount to
oh, right, yeah. I guess I didn't necessarily need to do that. Originally I was thinking like, I am going to have some state that I kind of produce at the end of answer query. And that will be like some set of numbers multiplied by each other. Some list of numbers. And then I'll like multiply all those numbers by each other, and then I'll multiply it by starting amount. But was thinking a little more and was like, oh, it seems a little clearer to instead have like kind of multiply starting amount in real time. Like that is, instead of like keeping some list around or something like that, like every time we kind of traverse across some edge, multiply starting amount by the value in that edge. So you just kind of keep a running total. But I think what I actually want there depends on like how I want to solve the underlying problem here. And I want to think about that for a second. Okay,
Sure.
So what do we want to do? I think like at a given node, we want to enqueue a tuple of like current amount and like unit to check or something like that.
What is unit to check?
Yeah, so let's see. This is going to be like, given we are at some node, it has some number of edges. We want to enumerate all of those edges. And for each of those edges,